Hello everyone. Today I'll be introducing our project on the steam boiler system as part of our control engineering assignment. A steam boiler is a critical device that heats water to produce steam, which is used for heating, power generation and various industrial processes. Our project aims to develop and analyze a control system to ensure this system operates efficiently and safely. Let's move on to our objectives. Our project has three main objectives. First, we aim to develop a mathematical representation of how the steam boiler system works, capturing its operating mechanism. Second, we plan to implement a simulation in MATLAB to regulate the boiler's pressure. Third, we will assess the stability of the pressure control throughout the system's operation. These steps will help us to understand and improve the system's performance. The scope of our project includes three key tasks. We will start by obtaining a solution for the mathematical model of the steam boiler system. Next, we will complete the simulation of the pressure regulation system using MATLAB. Finally, we will perform a detailed analysis of the pressure stability within the process. This structured approach ensures we cover all essential aspects of the project. Problem statement. One major challenge we are addressing is maintaining stable pressure in steam boilers. Pressure fluctuations can reduce efficiency and pose safety risks in industrial settings. Our project identifies the need for an effective control system to optimize performance, ensuring the boiler operates reliably under varying conditions. This sets the foundation for the rest of our group's work on designing and testing the system.
Hello, Assalamualaikum. My name is Najia Natasha binti Momansari. Today, I would like to talk about literature review. Introduction. Industrial process control refers to the management and regulation of equipment, system, and operation to maintain desired output levels while ensuring consistent quality, safety, and efficiency. It plays critical role across a wide range of industries, including paper manufacturing, food production, energy, biotechnology, chemical processing, pharmaceuticals, water and wastewater treatment, oil and gas, as well as the beverage industry. Due to the complexity of this operation, many sectors rely on highly sophisticated control systems to monitor, manage, and optimize their production process. Next is a component of industrial process control system. First, controller. PID controller adjusts signal based on error. PID. PLCS rush industrial computers for automation. DCS distribute control across plant subsystems. Two actuators. Valve control flow of liquid gas. Motor and drive control torque, speed, and position. Sensor transmitters, temperature, RTDS, thermocouples, pressure, manometer, transducers, flow meters, level, ultrasonic, radar, capacitive, human machine interface, HMI, real time data, system status, and alert for operators. Consistency and quality. Maintains key variable, uniform product quality, critical in-flight pharma, safety, prevents overheating of pressure and hazard. 3. Efficiency and cost saving, less waste, better energy use, low cost. 4. Regulatory compliance, meets standards for safety and environment. 5. Scalability and flexibility, easy to teach, upgrades and production chains, real-time monitoring and data analytics, support predictive maintenance, early fault detection. Thank you for
And then for the nucleus diagram with PID, we get the shape of um, the nucleus diagram with PID. So the shape is like a heart, and then it is equal. This is our some of our example using the MATLAB. Next, the second figure show that the step response with PID, without PID, with PID, and then some of trial and error method that we use using the MATLAB for the figure 4.6 step response with PID. You can see that they are very up and down curve, and then for the 4.7 step response with the PID, the graph is slightly straight from the bottom to the top. And then for the figure 4.8 step response with PID, um, they have a curve from bottom to the top. And then for figure 4.9, you can see from the starting is the straight line. Then at the end of the graph, we can see that they have like a trend, uh, biggest trend from up to down. And then for the figure 4.10 step response with PD, um, we get the graph that similar with 4.8, which is the curve from the bottom to the top. So based on the theoretical and analytical procedure, we can make a discussion for our topic, which is this study show how control strategy affect the system performance. Without a PID controller, the system is slow and unresponsive. The rush time is around 3200 seconds and the setting time is 5800 seconds. This is too slow for most applications. The open loop system is indicate a PID controller significant improved performance. Rush time drop to 6.5 seconds and setting time to 48.2 seconds. The controller balance speed and stability. There are some overshoot, which is 18.7%, but the overall system performance is much better. Individual controller I, PI, and PD have different advantage and disadvantage. The proportional controller is faster, which is 3.0 second rise time, but has an 88%
In Chapter 4, we first tested the steam boiler system without a PID controller, and the results showed that the system was very slow and inefficient. The rise time was 3200 seconds and the settling time was 5800 seconds, which is far too long for any real world application. After applying the PID controller, the system performance improved drastically. The rise time reduced to just 6.5 seconds and the setting time dropped to 48.2 seconds with only a small overshoot of 18.7%. The system became much faster, more accurate, and more stable. We also compared it to PI, and PD controllers. The P controller was the fastest, with a rise time of 3 seconds but had a very high overshoot of 88%, causing instability. PI and PD give better results but still couldn't match the balance achieved by the full PID controller. To support our findings, we used root locus, both and Nyquist plots, which confirm that the PID controller stabilized the system and enhanced its overall performance. In conclusion, the PID controller gave the best balance between speed, accuracy, and stability, making it the most effective control method for the steam boiler system.
Assalamualaikum, my name is Zaki Mirzulkarnain. I will present for you in Chapter 5, Conclusion and Recommendation. This research successfully demonstrates that a PID controller offers precise and stable liquid level control compared to P and PD strategies. Times and frequency response analysis show that the PID controller achieves faster settling, minimal overshoot, and reduced steady-state error. Root locus and boot and quiz plot confirm system stability under varying conditions. However, limitations such as sensor accuracy and slow response time highlight areas for improvement. It is recommended to enhance the system with higher precision sensor, real-time testing, and advanced control method. For example, adaptive or fuzzy logic. Future work also include modeling real-world distributed for better practical reliability.